arrangements with constants. Now let us do this question. This question says A, B, C, D, E and F go to a movie and sit next to each other in 6 adjacent seats in the front row of the theater. If B and D will not sit next to each other, in how many different arrangements can the 6 people sit? There is a constant here that B does not want to sit next to D, or vice versa. D doesn't want to sit next to B. So how can we solve it? First thing, let's not consider any constraint. Let's find out if all of them can sit next to each other, how many ways are possible. Since these are 2, 3, 4, 5, 6, so 6 factorial. These are the total arrangements. Okay, so total becomes 6 factorial. And let's say, rather than when we say 6 factorial, it was A, B, C, D, E and F. Since B and D do not want to sit next to each other, let's find out if they sit next to each other. All the arrangements in which forcefully B and C are made sit next to each other, then it becomes, let's say, A, B and D becomes one entity. Okay, C, E, F. So how many arrangements are possible now? B and D are together always. We are considering this one seat. So how many ways? The total 5 factorial. 5 factorial is when B comes first and D comes next to it. But there are other way rounds as well. D comes first and B comes second. Similarly, we again have 5 factorial ways this way also. D sits first and B next. Then A and this entity C, E, F. Now it becomes total 5 factorial again. Okay. Now these are the arrangements when B and D are together. If we subtract this number from this total, what we are remained with? We'll remain with B and D not sitting next to each other, and that is required. So answer is 6 factorial minus 5 factorial into 2 factorial, and this is 720. 5 factorial is 120 into 2, that comes 240. 720 minus 240, and that gives me answer 480. Okay, that's it.